Today we'll be looking at arithmetic progression. We will be looking at arithmetic progression. So we'll be looking at this set of numbers 3, 5, 7, 9, 11. So the first number is 3 and will be denoted as A1. Our second number is 5 and will be denoted as A2. Our third number, 7, will be denoted as A3. And our fourth number, 9, will be denoted as A4. While our fifth number, which is 11, will be denoted as A5. Let's just take a few seconds to observe the first number, 3. Then it moves to 5, and then it becomes 7. Then the next one becomes 9, and then the next one becomes 11. Is there a relationship? Now, in moving from 3 to 5, there is a common difference of 2. In moving from 5 to 7, there is a difference of 2. And also in moving from 7 to 9, there is also a difference of 2. In going from 9 to 11, we also have a difference of 2. So there is a common difference in these particular set of numbers. So we can call it an arithmetic progression. So let's just define what an arithmetic progression is in simple terms. So an arithmetic progression is a sequence in the sense that the numbers follow each other. And then the differences between every two consecutive terms are the same. We've established that one here. And if we use the above as an example, we'll see that in this particular sequence where we have 3, 5, 7, 9, and 11, we can clearly show that it is an arithmetic progression. Why? Because each of the numbers is obtained by adding 2 to the previous one. Each of the numbers is obtained by adding the number 2 to the previous term. So like we clearly stated, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11. So there is a common difference, and the common difference has been established throughout, and it shows that there is difference between every two consecutive terms, and that difference is the same. Therefore, we can say that it is an arithmetic progression. Sometimes the difference may be positive because now we are adding. In some other cases, the common difference might be negative. But provided it is an equal amount, then we still have it as an arithmetic progression. So sometimes, for instance, here we have a common difference of +2. In other cases, we can have a common difference of -2. As far as that pattern is consistent with the sequence, then we call it an arithmetic progression. So once again, let's look at the arithmetic progression. We have this set of data that we'll be looking at to be able to explain what our arithmetic progression is. So in order to get the difference, we will be subtracting the term A2 minus A1. So that gives us 5 minus 3, which gives us 2. And then when we now have A3 minus A2, So when you have a term and then you subtract the preceding term, that should give us the difference. So we can see clearly that when we subtract an existing term and subtract the preceding term, we have the difference. We have the difference. Now, in this particular case, we'll see that the differences are the same. That means they have a common difference. A common difference. And you see that the common difference here is 2. A common difference of 2. And that is denoted by D. So we call D the common difference. We call A1 first term, A2 second term, A3 third term, A4 fourth term, and A5 fifth term. Note that the numbers are actually subscripts. So we'll be looking at these sequence once again, and then we'll be making some additional sense from this sequence. So you notice that in this particular case, we have a finite arithmetic progression sequence, a finite arithmetic progression sequence. Why do we call it a finite arithmetic progression sequence? Because finite meaning that it has a definite amount of terms which we can count. In this particular case, finite because it has 5 terms, and then we call it an arithmetic progression because it has a common difference. So that common difference could be an addition, or the common difference could be a subtraction. And why are we calling it a sequence? A sequence is because we have each of them following, the numbers following each other. There's a comma. We are not carrying out any other operation in which in the following we'll see where we have a difference between a sequence and a series. So these same figures could be written as 3 plus 5 plus 7 plus 9 plus 11. In that particular case, it will be an arithmetic progression, but it will be in series. That is an arithmetic progression series. So we'll keep looking at this particular sequence, and let's see how we'll be able to determine each of the terms. That is how we can develop a general formula for each of the terms. Now, remember we said A1 is the first term, and A2 we obtain it by adding the common difference, which is 2. So our A2 is simply A1 plus 2, which can also be written as A1 plus D, because 2 is the common difference and it is denoted by D. Now let's look at A3. A3 will also be A1 plus the original 2, that is A2, and then we add an additional 2 so that it now gives us A3. So A1 plus 2 times of the difference will give you A3. And then let's look at A4 again. So in getting to A4, we will add A1. Then we'll add 2 plus 2 plus another 2. That is 3 2's. So A1 plus 3 difference is what gives us A4. Now let's look at A5. In getting to A5, if you look above, you will notice that you will add A1 plus 2, and then you add another 2, and then you will add another 2, and then you add another 2, and that gives us A5. So you have A1 plus how many 2's? 1, 2, 3, 4. 4 2's, which is 4 times the difference. Now, if you look at this, there is a pattern. There is a pattern, and that pattern says A1, all of them have, let's look at A5. So you have, at the end of the day, what do you have? You have A1 plus 4D. So it's the fifth term, but it's the multiple here is 1 less than the fifth term. Let's look at A4. You have the first term, which is A1 plus 3D is the fourth term, but it is 3D. So you also have 1 less than the term. Let's look at the same thing here. A3 is A1, that is first term, plus 2D, that is 1 less than the term. And that's the same for each of them. So we can generalize and say AN is equals to A1, that is the first term, plus N minus 1 times the difference, which we have clearly established here. So you can see that looking at it again, A2, you can see that is A1 plus D, A3, A1 plus 2D, A4 will be A1 plus 3D, A5 will be A1 plus 4D, and then AN will be A1 plus N minus 1D. So that's very clear. So this gives us the nth term in a particular sequence of arithmetic progression. This gives us the nth term in an arithmetic progression, AP. So let's take note of this. Let's take very note of this. We'll be using it regularly. So we're looking at the arithmetic progression 3, 5, 7, 9, and 11. And this formula we see, sum of n terms, is simply n divided over 2 into the bracket of the first term plus the last term. The first term plus the last term is what multiplies n over 2. So this A1 is the first term, which is 3, and then AN is the last term that you want to find the total sum of. If I say I want to find the sum of these arithmetic progression, all the terms here, so that means my last term here will be 11, and then my first term, of course, will be 3. What if I want to take the sum of just the first 4? That means my first term will be 3, and then my last term, which is AN, will be 4. And of course, my N here will be 4 because I'm finding the sum of the first 4. So this is the formula for finding the sum of n terms in an arithmetic progression. So we can expand that. We can expand that term to give us what we're seeing above. So you know that your A1 is the same A1 here. Your AN, your nth term, remember we established it previously that your nth term is A1 plus N minus 1D. So what we just did was to substitute the AN for this term, which we have already established previously. So let's simplify. You know that A1 plus A1 will now give us 2A1, and that helps us in the simplification. So we have, I'll say, two ways of expressing the sum of n terms. It's expressed either in the form of the first term and the last term, and thereby multiplying by n over 2, or you can look at it this way, n over 2 multiplied by 2a plus n minus 1 into the difference. So these are the possible ways of finding the sum. Now let's take an example. If we want to find the sum of these 5 terms, so we'll say the sum of n, instead of n now we'll say 5. So let's even do it together before even working it out here. So what is our n? Our n is 5. Let's use this particular equation that I'm highlighting. What is our n? N is 5. So we have a 5 over 2. What is our a1? Our a1 is 3. What is our a5? Because we're looking at the first 5 terms. So our a1 is 3 and our a5 is what? 11. So it will be 3 plus 11. If you add 3 and you add 11, what do you have? 14. Remember, we have 5 over 2 and then we now have 14 here. So 2 can go into 14, 7 times 5, which is 35. So our S5, that is the sum of all these terms, is 35. Let's quickly add and see. 3 plus 5, 8. 8 plus 7, 15. 15 plus 9, 24. 24 plus 11 is 35. So we are correct, but let's see the workings. We will substitute. So what we are doing simply is to use this first equation. So we have n over 2, and our n is 5 because we are finding the sum of the first 5. So we have n over 2, that's 5 over 2. And then a1, we said our a1 is 3. a1 is the first term, so we put 3 here. Then our an is the last term. That's the 5th term in this particular case because our n is 5. So we have 11. So when we simplify further, what do we have? 5 over 2 times 14. So 2 in 14 will be 7. 7 times 5 will give us 35. So we had done that previously. So that's using this particular formula. Let's see whether we can just quickly use this formula below to see whether we'll get the same answer. So our Sn is as shown using that formula. That's the formula. So we'll simply substitute where our n is 5. So anywhere we see n, we'll put 5 because it's the first 5 terms we're looking at. And then anywhere we see a, we will put 3 because 3 is a1. And anywhere we see d, the difference is 2. The common difference is 2. So we just substitute. So we have 5 over 2, that's n over 2, 2a, 2 times a, our a is, a1 is 3, so we put 3 here, plus n minus 1, our n is 5, 5 minus 1 times the difference. So 5 minus 1 is 4, 4 times 2, we'll have 8 here, and then we have 2 times 3, which is 6, so we have 6 plus 8, we'll have 14 in that particular bracket. So we'll have 5 over 2 times 6 plus 8, and 6 plus 8 is 14. So 5 over 2 times 14, and therefore we have 35, because 2 will go into 14 7 times, and 7 times 5 is 35. So we have shown the 2 different methods to be able to find the sum of those 5 terms. So once again, we are looking at this same arithmetic progression. We are looking at this same arithmetic progression. So we have 3, we have 5, we have 7, we have 9, we have 11. And Assuming we're supposed to get the sixth term in this arithmetic progression, what will it be? It will simply be A5, which is 11 plus 2, and that will be 13 because we have a common difference of 2. So once again, this particular arithmetic progression sequence is finite and it's a sequence. It's finite and it's a sequence. Now, the moment we have dots after the 11, it tells you that it is a continuous unending sequence. It is a continuous unending sequence, and therefore it means that it becomes infinite. It becomes what? Infinite. So now what we're going to say is that 3, 5, 7, 9, 11, and because of all those dots, we'll now call it an infinite, but it's still an arithmetic progression sequence. This is just for clarity. So we'll look at these same numbers, 3, 5, 7, 9, and 11. But this time around, we are adding them up. So it is still an arithmetic progression, and it's still finite because we have a specific number, in this particular case 5, but we call it series. We call it a finite arithmetic progression series because we are carrying out an operation of addition. Now, the moment you have this same arithmetic progression series below, but with the dots mean it goes on and on. It now becomes infinite. Infinite means unending. But of course, it is an arithmetic progression because there is a common difference between the two terms. The preceding terms and the subsequent terms have common differences of 2, but we don't know where this series is ending because of the dots. So therefore it's infinite, and because we are carrying out an operation, it is a series. So that's just that about the arithmetic progression. Now we'll quickly look at examples questions so that we can solve and have better understanding. Now question 1 says, find the general term of the arithmetic progression. Find the general term of the arithmetic progression. 3, 5, 7, 9, 11. So we want to know the general term. Now we remember that an, that is the term n, is equals to a1 plus n minus 1d. It's very important that you have this formula handy, and the more we practice, the more we don't need to cram because we'll be utilizing it regularly. So what is our a1? Our a1 is 3 because a1 represents the first term, n represents the number of terms, d is the common difference. So what do we know? Do we know what n is? We don't know what n is. We don't know the number of terms that we will be for the general equation. So let's leave it as n. But we know what the common difference is. And the common difference is 2. So a1, which is the first term, is 3. And d, which is the common difference, is equals to 2. So what we'll just simply do is to substitute into that equation. Wherever we see a1, we put 3, and wherever we see d, we put 2. So that gives us an is equals to 3 plus n minus 1, and then times 2, because d is equals to 2. And let's just simplify that. We have an, which is equals to 3 plus So 2 will multiply the n, it will be 2n, and 2 will multiply the minus 1, and that gives us 2. Now, if we look at this, we can simplify. So 3 and minus 2 are like terms. So 3 minus 2 is plus 1. So we have 2n plus 1. So we have an is equal to 2n plus 1. So this is the general term of this particular arithmetic progression. This is the general term for this arithmetic progression, and what we have is an is equals to 2n plus 1. So let's test this arithmetic progression general term. Now let's say n is 1. What happens when n is 1? So anywhere you see n, you put 1. So if you have 1 here, a subscript 1, and then 2n, that means 2 times 1, because our n is 1, plus 1. So 2 times 1 is 2, 2 plus 1 is 3. And that shows us that our a1 is 3, as we can see. Let's try also for where n is 2. So where n is 2, so we substitute 2n. So n is 2, that's 2 times 2, 4 plus 1, that's 5. So that gives us a2. Let's also try for a3. So that means wherever n is 3, we'll substitute. So 2 times 3, 6 plus 1, 7. So this generally satisfies the above even when we continue to the end. So it tells us that an is equals to 2n plus 1. That is, a subscript n is equals to 2n plus 1 is correct. So why do we need this general term? So here we have 5 terms. If we wanted to calculate the 100th term, what would the 100th term be? That will just be by substituting where n is equals to 100. So we don't have to be adding manually. So if we want to get the 100th term now, we'll say n is equals to 100. So that tells us that 2 times 100, 200, plus 1, 201. So the 100th term is 201. Why? Because we have established a general form of this arithmetic progression. Now let's go to another question. Let's go to another question. So the question says that which term of the arithmetic progression, 100, 96, 92, 88, 44, and so on is 0. So you can see that the common difference here is minus 4. So if you add minus 4 to 100, you get 96. You subtract 4 again, you get 92. So you keep adding minus 4, and then it keeps reducing by 4. So as you keep going on, you get to 0. So the question is, which term? Is it the 5th term? Is it the 20th term? Is it the 30th term? When will this arithmetic progression get to 0? Which term will it be? So all we just need to do is to write the general equation of the nth term, which is an is equals to a1 plus into n1, n minus 1, bracket close, times d. So in this particular case, we know what our a1 is. a1 is the first term, and clearly shown there it is 100. And we know what our difference is. Our d, which is a common difference, will be minus 4. So what we can simply do is to substitute it into the a subscript n is equals to a1 plus n minus 1 times the difference. Let's substitute that and see what we get. So our a1 is what? 100. So a subscript n is equals to now what? 100. We're using this equation. So wherever we see a1, what do we put? We put 100 because a1 is the first term. So that's why we have 100 here, plus n minus 1d. N minus 1, what is the difference? Our difference is minus 4, so we put the minus 4 here. So let's expand this. So we'll say minus 4 times n, that will be minus 4n. And then minus 4 times minus 1, we will have plus 4. So let's see what we have. So that will be minus 4n plus 4, just as we had said. And then 100 can add 4, so that becomes 104. And then we have minus 4n. But the nth term is 0. The nth term is 0. So wherever we see an, we put 0, and then we equate it to this, and then we solve for n. So we have 0, which is now equals to 104 minus 4n. So what we will do is to take this 4n to the left-hand side. So it's minus 4n. The moment it crosses the equality sign, it now becomes plus 4n. And by the time it adds 0, it still remains 4n, because 4n plus 0 is still 4n. So you have 4n on the left-hand side, and you equate it to 104. Now, for us to be able to solve for n, we will divide both sides by 4. So we now have 4 is 104 divided by 4. And if you divide 104 by 4, you have 26. So 0 is the 26th term. 0 is this 26th term, because we have solved for n, and n is 26. It is n that is equal to 26 that satisfies the equation. So 0 is the 26th term in this particular arithmetic progression. Now let's look at another question. This is question 3. Now the question says, find the 5th term of the arithmetic progression. Find the 5th term of the arithmetic progression whose first term is minus 70. That tells you that A1 is minus 70. And the common difference is minus 5. That is, A1 is minus 70 being the first term, and the common difference is minus 5. That is, D is equals to minus 5. So let's solve. Now the general equation for nth term is an, that is a subscript n, is equals to what? A1 plus what? Bracket open n minus 1 times what? D. Where our an is the nth term, our a1 is the first term, and then n minus 1 times d, where n is the term we're looking for, in this case 5th term, so n will be 5, and then d is the common difference, and that common difference in this particular case is minus 5. A1 is the first term, and we can see clearly that our A1 is spelled out clearly that our first term is minus 70. So let's just write it out. A1 is what? Minus 70. That is A1, which is the first term, is equals to minus 70. And then our difference is equals to what? Minus 5. So we can simply solve for the 5th term, because in this particular case, our n is equals to what? 5. So A5, because n is equals to 5, is equals to A1, that's minus 70 plus 5 minus 1 times 5. So all we are doing is we're using this equation. We're using this equation. So what is our n? Our n is 5, because we're looking for the 5th term. What is our A1? Our A1 is the first term, which is minus 70. So we put minus 70 here. We are simply substituting. A1 is minus 70. And then plus, we have our positive sign. Then times n minus 1. N minus 1 here. So what is our n? Our n is 5, because we are looking for the 5th term, so 5 minus 1, times the difference which is d, and our difference is minus 5. So let's simply simplify this. So in this bracket we have 4, 5 minus 1 is 4, and then 4 times minus 5 is minus 20. So what we have there is A5 is equals to minus 70, and then plus 4, which is 5 minus 1, 4 times minus 5. And like I said, 4 times minus 5 is minus 20. And then when you have minus 20 and then you open this bracket, it still remains minus 20, because minus times plus is minus. The minus will always have a more dominant effect. So what we have is A5 is equals to minus 70 minus 20. So minus 70 minus 20, you're owing 70, and you're going to owe another 20. So a total of 90, which you'll be owing. So A5 will equals to minus 90. So this tells you and me that our fifth term of the arithmetic progression, where the first term is minus 70 and the common difference is minus 5, is minus 90. Let's just do something like a quick check. The check is such that, assuming we did not know how to use the arithmetic progression formula, and we wanted to see what the fifth term of the arithmetic progression is, knowing fully well the first term, which is minus 70, and then also having an idea of the common difference, which is minus 5. So we know that our A1 is what? The first term, which is minus 70. And then our difference is what? Minus 5. So we can simply get the second term. What we'll do is we'll add minus 5 to this first term. By the time you add minus 5, positive and the negative, so it now becomes minus 5. So your A2 will simply be minus 70 minus 5, which is minus 75. You're owing 70, you're now owing 5, you owe 75. So that is A2. So our A2 now is minus 75. So how do we get our third term? So it will be A2, and then we add another minus 5, or we subtract 5, which is minus 80. We do the same for the fourth term. We now have A3 minus 5, which is minus 80 minus 5. We have minus 85. And then the fifth term, which is A5, we'll obtain it by adding that common difference, that is, we're subtracting 5. And then we have A5, which is the fifth term, to be equals to minus 90. So you see that that also corresponds with what we had before using the arithmetic progression formula. But we won't be able to be doing this manually like this if we have very large numbers, and thus the need to be able to understand how to get the nth term using a subscript n is equals to a1 plus into the bracket n minus 1 times the difference. So let's look at another question, question 4. So this question says, what is the common difference of the arithmetic progression whose A18, that is the 18th term, minus the 14th term gives us 32? I read again. What is the common difference of the arithmetic progression whose 18th term minus the 14th term is equals to 32? So what do we do? So let's just write the general equation for the nth term, which is an is equals to the first term plus n minus 1 times the difference. So now A18, let's express this in this form. So A18 will be A1. What is A1? We don't know what it is, so we simply write A1 plus, what is our n? Our n is 18. So 18 minus 1 times the difference. So 18 minus 1 is 17. So we expect to get plus 17d. So if we simplify that, we have A subscript 18, that is the 18th term, is A1 plus 17 difference, 17d. Now, let's also express A14 using this nth term equation. So what do we have? We have A subscript 14, that is the 14th term, is A1, which we have here, plus, what is our n here? This time around it will be 14. 14 minus 1, that will be 13 times the difference. So we have 14 minus 1 times difference. So at the end of the day, we'll have A14, which is A1 plus 13D. So we have expressed and simplified A18 as what? A1 plus 17D. And we have also expressed A14, that is the 14th term, as A1 plus 13D. So but remember from the question, it says that the common difference of A18 minus A14 is 32. So let's see what we have expressed and simplify. Now, remember previously we just established that A18 is equals to A1 plus 17D. And we also expressed that A14, that is the 14th term, is equals to A1 plus 13D. Now let's subtract A14 from A18. That is, this equation should subtract this equation. So let's look at the left-hand side. So on the left-hand side, we'll have A18 minus A14. And then on the right-hand side, we look at the like terms. So A1 should subtract this A1. So we have A1, it will subtract the A1. And then we'll now have 17D minus 13D. So you have 17D minus 13D. So let's group it together clearly, just as we have done. By the time you have A1 subtracting A1, it cancels out, it becomes 0. Then 17D minus 13D becomes what? 4D. So what we have established is that A18 minus A14 is 4D. That is, the 18th term minus the 14th term is 4D. But we have also established in the question that A18 minus A14 is equals to 32. So if this is equals to 32 and this same is equals to 4D, it tells you and me that 4D is equals to 32. 4D is equals to 32. Remember the question says 18th term minus the 14th term is 32. And we have simplified term 18 minus term 14 using the nth term equation, and we have established it to be 4D. So it tells you that 4D is equals to 32. And then if we divide both sides by 4, we have D is equals to 8. So dividing both sides by 4 in order to solve for D, we have D is equals to 8. Therefore, the difference which the question asks is the difference is equals to 8. The difference is equals to 8. Now let's look at question 5. Now, how many terms are there in the arithmetic series? 1 plus 3 plus 5 plus 7. Notice that there is a dot dot here, but it also goes as adding up to 75. So this tells you and me that the first term is what? 1, and then the last term is 75. First term is what? A1 is 1, and the last term is 75. But we don't know what this last term is in terms of the terms, the nth term. So let's just simply write the formula. An is equals to A1 plus n minus 1 times d. So we don't know whether this 75 is the sixth term. No, it definitely is not the sixth term. We don't know whether it's the 25th, 26th, 27th term, but it is in this series. So this will help us to establish that. So a subscript n is equals to A1 plus n minus 1 times the difference. What is our A1? Our A1 is the first term, which is 1. What is our difference? Our difference is 2. So A1 is 1, A2, or I'm sorry, pardon me, D, which is the difference, common difference is 2. So AN will substitute into this formula. AN will be equals to what? A1, which is 1, plus n minus 1. We don't know what n is, so we say n minus 1 times the difference. The difference is 2, so we'll put 2 here. So we'll simply expand. So an will be equals to 1 plus, so 2 times n will be 2n, then 2 times minus 1 will be minus 2. So we have 2n minus 2. When we expand this bracket, open it up, 2 times n will give us 2n, and then 2 times minus 2 will give us, 2 times minus 1 will give us minus 2. Let me just quickly come again. 2 times n will give us 2n. 2 times minus 1 will give us minus 2. So let's simplify. So 1 and minus 2. So 1 minus 2 is minus 1. So when we simplify this, we'll have an is equals to 2n minus 1. So this is the general term for this particular arithmetic progression series. But we know what the an term is. In this particular case, 75. So we'll solve for n. This is the series. Remember, it is a series because we are adding. It has a common difference of 2. And the first term is 1. Remember, we established that the nth term for this particular series is given by a subscript n is equals to 2n minus 1. But the nth term we have in this particular case, this is the nth term, which is 75. But we'll need to solve and we'll need to equate it to 2n minus 1 in order for us to solve for n. Now, what we'll do is to group the like terms. So we have 75 is equals to 2n minus 1. We'll solve this equation. We'll take minus 1 to the left-hand side, so it becomes positive. So we now have 75 plus 1, and that will be equals to 2n. So 75 plus 1 is 76, and that's equals to 2n. For us to solve for n, we divide both sides by 2. We're dividing by the coefficient of n, and the coefficient of n is 2. The coefficient is simply whatever is multiplying the variable of interest. Our variable of interest is n, so the coefficient of n will be 2. So we divide both sides by 2 in order to solve for n. So 2 cancels 2 on the right hand side, we're left with n. 76 divided by 2 is 38. So n is 38. Therefore, 75 is the 38th term. 75 is the 38th term in this particular arithmetic progression. Thank you.